we want to use, we are going to use it a little bit in the SaaS business here at Adora, and we hope to use it more and convince some customers of this and so on. So, but that's just introduction.
I can hopefully give you the tools to do that.
So listen, all people working for Adora will get to use this.
And then what will happen after the presentation?
Pizza. Exactly. So you're a seasoned presenter? Yeah. Okay.
I mean, what you've basically done is put me between them and pizza. So, no pressure.
No questions.
I mean, that's the thing. Is that entire question section is what's going to stop you from getting pizza. So, make the questions easy. Is that the whole intro? Should we just get started?
Yeah.
Awesome. So, this is a modification of a talk that I've been building for quite a while now around OpenTelemetry being a kind of new thing to a lot of people, and people wanting this talks on, oh, what's this new thing? And we're kind of past that now. OpenTelemetry is the #2 project from the Cloud Native Computing Foundation. Their #1 project is something to do with containers or something, Kuba something, I don't know. Apparently it's a big thing.
You do know.
Interestingly, I met a few people today that manage container shifts, and they use Kubernetes to do it. So they're managing containers with containers. So that was pretty interesting. But essentially where we're getting to now is it's not the new thing anymore. And people are like, great, okay, you told me this awesome thing exists. But how do I do it? Like, what are the things I should be doing with this thing that you've told me is awesome? And that's where the idea of doing some practical and hands-on type things came from. My name's Martin Thwaites. I go by martin.net on the Twitters and Mastodon and all that kind of stuff. I'm first and foremost an observability advocate, and we'll get into what observability is. But I'm also a developer advocate for a company called Honeycomb, who develop back-end products off the back of OpenTelemetry, and we'll go into what that means. I'm also a Microsoft MVP very recently, but follow me if you want some snark about, with a sort of British stint on it. You've been warned. If you follow me, that's what you're in for. So we can't really talk about OpenTelemetry without first starting with why. And that is where observability comes in. So we have to really understand why we're doing these things. So what is observability? So our co-founder at Honeycomb came up with that definition of observability. Now, it's not a new concept. Observability comes from something called control theory in science. And it's this idea of how do I understand what is happening in a reaction from the outputs that I get from that reaction. Now, if you get that, what is it called, the Large Hadron Collider thing, and you blast two atoms together, you can't see what's happening inside of that reaction. You've got to infer what's happening inside of that reaction from the outputs that you see. So Charity came up with this idea on translating that concept into software, around this idea of understanding and debugging the unknown unknowns, so the things that we didn't know that we needed to know, because if we knew that we needed to know them, we'd put something there that measured that thing. But it's also about understanding that inner system state. What's happening inside of our production system that we can't attach a debugger to, because everybody's tried attaching a debugger to a production running system. And I say tried because they've done it once. Nobody does it twice. Because it stops all the threads on the server, everybody stops being able to do anything, and then you get fired. So the idea is, how do we understand that inner system state, because we need to know what's happening in production, from the outputs that it gives us. I want to be really clear, because if you follow people online that are in this space, you will see a lot of terminology around observability, which isn't really what observability was meant to be. Observability is really just about asking questions of your production system. It's about saying, well, what was the impact of the change that I made? It's about saying things like, that code that I just wrote, is that actually being used by anybody? The feature that I wrote, is anybody using that feature? It goes as far as things like the actions, the URLs. Did I change the response time of that URL based on what I've just deployed? Because I only deployed it when these conditions are met. So you might be able to, from metrics, be able to surmise that your auth route is running slower after you've done a deployment. But you don't know whether that was to do with the fact that you did an auth route, but it only affected certain groups. That's the thing that you didn't know that you needed to know. And that's where unknown unknowns come in, because these are questions that you want to be able to ask your system. You obviously use third parties, everybody does. It's like that exchange rate system that we're calling, the user detail system, the medical detail system that we're calling. How are they responding? Are they responding slower or faster? Does that matter to me? Is that affecting customers? But when we're running either in the cloud or we're running multi-data center, we might be running across 2 regions, we might be running across 2 availability zones inside of the same country. We might have a whole networking team that are there building out all of these interconnections so that we can have resiliency between our 2 data centers. All of a sudden, that is something that could affect our users. And we don't know whether those things are important until we need to know them. And for many, many years, people have used logging and log levels to get this level of information. And we all know that the error happens when you don't have the logs. It doesn't happen when you then go in and add the logs and do a new release. The only way to fix a bug completely is to add logs to see whether the bug happens, because then it doesn't happen. So why does observability matter? Well, engineers are overworked. And I'm sorry for the managers in the room. Yes, you're overworking your developers. I'm sorry. It's a thing that happens. But we're getting to the point now where we're asking the engineers to ship more. The expectations from customers are that we get releases every hour, every day, every commit, every week. That is different than when we used to do this. We'd have 6 monthly release cycles. We'll release next month. It's fine. And then you'd have big, massive QA cycles. It's not because people are saying that they just want it for the sake of it. They want it because customers want it. We're saying, well, while you're also shipping this every day, can you also make the code better? You know, so can we ship it more and make it better? Great, okay, I can do those 2 things. Okay, but can you also stop fixing bugs and actually create value? So stop creating any bugs so you don't have to fix them. And while you're also doing that, can you make sure you don't have any downtime? Like, we're asking people to do these things, more of these things, while also doing the things that they did before. And if we don't provide them with better tooling, better methodologies to doing that, then we're not going to be able to do those things that people are asking us. Because our production environment is changing. If you're working in a system that is, let's say, microservices, modular monolith, distributed monolith, and what's the term for this week? I can't remember. The term keeps changing. But we get into this phase of, we need to know more about our system now. It's not just one deployment, and you hit the system and you can follow that through. Things are getting a little bit more challenging because we're getting to the point where we're a little bit afraid to break things. Because if we do break things, the risk is so much higher. We're closer to that production system, therefore we're more at fault now. Which brings in the aspects of psychological safety. People do less things because they're afraid to break things. Now, this one's particularly important for me because my memory's going, I'm getting old. I can't remember what I did yesterday, never mind what I did in 2 weeks. 2 weeks ago. So by the time it gets to the point where we've actually pushed stuff out, in a month's time, 3 months' time, so much more has happened, and I can't remember how to fix that thing. And most importantly, when it does go wrong, how do I find out what went wrong and fix it quickly? Because there is so much pressure when things go wrong now, because we're in a 24/7 society, where things are being deployed constantly. People are using our systems all day and every day. It's no longer that these systems work from 9 till 5. If it's past 5 o'clock, it doesn't matter. Oh, the weekend, nobody uses IT on the weekends. Everybody's out having fun. No, these are things that we have to have up and running all the time. So finding and fixing issues really quickly is important. Now, this is a report from somebody called Dora. Well, it's the Accelerate State of DevOps, which is by Google and a few other people. They came up with 4 key metrics on how you should be monitoring your processes to have high-performing teams. They came up with 4 distinct metrics that should be interesting to you as engineers. These aren't things for managers to use as a stick to beat people with. They're how you as engineers know whether you are doing better. I advise people to look at these in retros, keep them internal to your team so you know how you're improving. It comes down to deployment frequency, how often are we deploying? It comes down to lead time of changes. So from the time that I inept, you can kind of measure that from a few different ways. There's no distinct way. It might be from ideation, I want to do a thing, through to customers are using it. It could be measured from I finished the code and now customers are using it. But the key is it's for when customers are using it. And shortening that period has been proven to make high-performing teams. It's also time to restore. And that's about the idea of if something goes down, how quickly can I get back? That might be a rollback, it might be a roll forward, it might be a fix, it could be anything. And then finally, the change failure rate. How often do you deploy something and you see a failure from that thing that you've deployed? Now, all of those things feed into observability. And more key, they ran this report and this is one of the statements that they came off the back of it. And this is the thing I like to highlight, is that the research shows that if the teams that have more observability, have modern observability systems that they use against their deployed systems, write more code. Now, I don't know about you. As an engineer, I like writing code. And I'm not saying that they write more code to fix more bugs. I'm saying they write more code because they're not fixing things. They're not investigating things. Observability gets us there. And OpenTelemetry is part of that. So what is OpenTelemetry? Now, I mentioned the CNCF. They have sponsored OpenTelemetry. It comes from 2 projects that were around for many, many years. One called OpenCensus and one called OpenTracing. Now, back in 2017, they decided to merge. It's the first time in the history of ever that 2 open source projects have decided that they're actually going to both merge and not compete with each other. It's a historic occasion. We've all seen the XKCD of, we have 12 standards. We need one unifying standard to unify all of the standards. And the outcome is we now have 13 standards. Well, that was what everybody thought was going to happen, that OpenTelemetry would be the 3rd standard. In the last few months, OpenTracing and OpenCensus have both closed their doors. OpenTelemetry is the only game in town for this kind of stuff, except for vendor-based telemetry systems. Now, at its heart, OpenTelemetry is a protocol. It's how do I transfer information, telemetry information from my production systems to a back-end system that can monitor it, that can allow me to analyze that data. That is why OpenTelemetry is so important. Forgetting about the other things that OpenTelemetry do, and we'll go through some of those, the protocol is the most important thing. That is how we're able to make a decision about using OpenTelemetry and not choosing where it goes at the start of the project. Many, many years ago, when you started a project, the first 6 months of any project was choosing which logging framework we're going to use. Is it nlog, log4net, serilog, which one we're going to use? Because it went throughout your entire system. Every single class would be touched by the library that you've done. And if you don't make the right decision, it's going to take you a long time to revert that back. .NET brought in something called iLogger, which solved that debate because everybody just uses iLogger in their systems, and they just set up where they're going to send that logging data later. OpenTelemetry is pretty much the same concept. You put OpenTelemetry in your code, and then you can choose where that goes later. So the protocol is one of the most important things that they give. Now, they also use SDKs, and SDKs allow you inside of your application to produce that protocol data for you to be able to transfer that telemetry data out. They provide instrumentation libraries and various other things that allow you to generate that. We'll go through some of those libraries today. Now, this is something I want to really, really try and ram home a little bit, is this word signals. Now, when you start researching observability or open telemetry, you'll start hearing words like 3 pillars of observability, which implies that you need all of the 3 pillars in order to have observability. Now, I told you what observability was, and there was no mention of logs, metrics, or traces in that definition of what observability is. These are signals that can help you understand your system. You do not need all of them. You can choose which ones you use. If you can answer all of the questions that you would possibly need to know about your system from just logs, just metrics, or just traces, you only need one. Because observability is about how do I answer those questions. So in .NET, traces are stable and robust. Metrics are also stable. Logs are only the protocol is stable. The SDKs are in beta. Honestly, I know people who use these in production at massive scale, so I wouldn't worry too much about the fact that they're not stable in .NET. We've had iLogger for a very long time, and all this does is it's an output from iLogger. So don't worry about those things too much, but they are pretty much all stable. Okay, now key concepts about tracing. We're going to concentrate on tracing because tracing is one of the most robust and versatile signals that you can use while you're pulling observability in. We will touch on logs and how to use logs very briefly because you've used logs before, everybody's used logs, they're not really that interesting. And a lot of the concepts that will apply to tracing will apply to logs as well. So what is a trace? A trace is defined kind of as a thing that is done. It's a context. In the context of, say, a website, a trace would be a web request. It would be the initiating web request into your modular monolith or your monolith and encompasses everything that you need in order to fulfill that request or anything of the side effects from that request and allows us to trace through a system to see how did a request interact with different components of our system. It isn't, however, something that we create. We don't go create trace. We don't call an API in a backend and say, create me a trace. What we do is we create spans. We create a load of spans, and as long as they have the same trace ID, they are considered to be a trace together. So a trace itself isn't a thing that we create. That's the key thing that you need to know. There's no create trace API. There is a create trace ID in a lot of the frameworks, but there isn't a create trace API. Okay, so I've told you that we've got a lot of spans in there. What does a span? What is a span? You can think of it as a structured blob of data. I would imagine that most people have heard the term structured logs, and they're using something like Serilog or even nlog to create structured logs in their application, or if you're not using .NET, most of the languages now have some kind of structured logging. So if you think about a span as a blob of data, it's got a few properties that are mandatory. It's got a unique ID that uniquely identifies that particular span. It has a correlation ID. You've heard of correlation IDs before. That's something pretty common. So the unique ID we call a span ID. The correlation ID we call a trace ID. It has a property called duration, which is always measured in milliseconds. It's got a timestamp of when this particular span started. So if you see those two together, you know that we can say it started here, finished here, so we can show a blob. The most important, though, is something called a causality ID, which we call a parent span ID. which is the span that was active when this particular span was created. And that's how we can create really cool trace waterfalls like you can see on the right-hand side, which allows us to be able to then transition through the system, say it took this long for doing this action on this system, and that relates to this whole user context, this web request, because of these things. And that bottom one there is really what makes tracing so much better than logging. I'm not saying logging is bad. If you're using logging and you can do all the things, that's great. But if you have a log, you've probably got these two already. You've probably got a timestamp. If you add on a duration, and then also add on your causality ID, you've got a span. And that allows you to do so much more with your systems. I mean, really traces are just fancy logs, really. There's not that much special about them. Okay, so what is a log then? The key characteristic of logs is they're designed for humans. They're designed for humans to read in a linear fashion. So you see it on your console output. This thing happened, this thing happened. You see it there going here, here, here for, I was also here, that are left in there for years and years to come. We always have them. But they are useful. They're useful for things like access logs because there's no context. You don't generally have a correlation ID for access logs. Audit logs, again, very similar. So when we talk about logs, we're still talking about structured logs, but that's really what we're talking about when we use logs. They're also really good for debugging whether your tracing's working as well. I have a whole blog post on that, and I'll send the stuff over to you so people have got some material. I mean, mostly logs are fine. If you want to use logs, it's fine. If you look closely, you can see what's burning at the bottom there. But logs are very verbose. They're very big. They use up a lot of data. They also don't allow for things like sampling and various other concepts that traces provide that make them far superior. Okay, so let's talk a little bit about how do we get OpenTelemetry into our applications. Now, the first one I'm going to talk about is something called automatic instrumentation. And this is for when you don't have access to the code, or you just want to get started. It's a codeless integration with OpenTelemetry. You can add a few lines. We'll show you the lines in a minute. You can add a few lines of code to the startup of your IIS, or if you're using Docker and deploying things in containers, you add it to your container, and it will just auto-instrument everything for you. Use things like environment variables to configure it, to turn things on, to turn things off. By default, it's going to do everything, which means that you do have some performance issues because you're essentially side-loading something into your application that wasn't meant to be there at the start. But like I say, this is really good for getting started. If you've got a ton of teams, a ton of applications that you can't go through and change because you've got change control and all of that kind of stuff, but changing infrastructure is easier, using something like auto-instrumentation allows you to just sideload in the agent, similar to what you might have done with APM providers in the past where you install an agent on the machine. Very similar, and you will get tracing data, logging data, and metric data out of the standardized libraries. The thing I will caution you against with this is it's very verbose. It produces a lot of data. It might be more data than you need. So think about this as an iterative approach. Everything I'm talking about today should be an iterative approach. Because what you're doing is you're designing the debug experience for your fellow engineers to say when things go wrong, here's a big set of information that you can do. What you don't want to do is say, here is a massive set of information that I'm going to ask you to go through and you don't know where you're looking. Providing concise debug experiences is really important. So that's just a few of the libraries that will be auto-instrumented when you imply these things. The Azure SDKs, there's actually AWS SDKs, MySQL, Postgres, SQL Server, Mongo, Redis, GraphQL, all these things are out of the box and they will just be applied when you do this. It's Really, really simple to do. If you're on Windows, using PowerShell, download the package, you can import the module, add OpenTelemetry, set the session variables, and then run your app. There's ones for iOS as well, and if you're running on Docker or Linux, you can do it through Bash, and you just add some environment variables before you start your application. It's not complicated. And this is why I talk to people about you're doing logs, you're probably still doing a load of stuff inside of your startup to try and get centralized logs out. This is actually easier. And it means what you're going to be doing is sending logs, metrics, and traces just by adding this. You can actually rip out your logging and replace it with this. But this is step one. It should never be the end goal. This is about saying, this is valuable, tracing is valuable to us. Look, here you go, this is what we're going to get if we put the effort in. And then we can refine it. And we...
Just to clarify, this is not something that you recommend to go to production, but it's...
Yeah, I would recommend doing this in production, 100%.
But at a significant performance cost?
There is a performance cost. It really depends on what you're willing to accept. Because if it adds 100 milliseconds onto a 5-second request, you're not going to notice it. If it adds 100 milliseconds onto a 10 millisecond request, you're really going to notice it. You can turn off the instrumentations and you can tweak all of these individual instrumentations. What you cannot do is what we're going to go through here, which is adding additional context. The context that matters to you in your applications that you know about. You know what IDs are important. You know what session is. You know where user ID is stored. These are things that you know about your system that are important. You can't do that with auto instrumentation. And that's where all of this comes into its own. So setting up the signals, and this is the boring part, because I'm going to show you 3 sets of 4 lines of code. It's boring. It's not hard. So if we're doing logging, you'll notice this is a pre-release package. As I say, logs at the moment, only the protocol is stable, not the SDK. That's the reason why that's in pre-release. I can give you reference sites of people that are using this at millions of log lines per second scale. It's robust. But CNCF is a massive organization. They have release processes. And until things have been marked as stable, we can't release a stable package. I hate it, but it is where we're at. You want to do metrics? Great. A couple of other packages. Notice these don't have pre-release because everything's good. Again, 4 lines of code. You want to do traces? Guess what? Same 2 packages, 4 lines of code. What we've done there is we've replaced a lot of what the auto instrumentation has done by just saying I want to set up OpenTelemetry. I want to send any of my data to what's called the OTLP exporter, which means I'm going to export the data using the OpenTelemetry line protocol. Now, it's OTLP, not OLTP, because those are 2 very different things, and I always get them mixed up. It's the OpenTelemetry line protocol, not online transaction processing, which are 2 very different things. But what that's doing is it's saying any telemetry that's generated that I know about, send to OpenTelemetry. So send to this endpoint via the OpenTelemetry exporter. By default, there are some sensible defaults. We've spent a lot of time in the OpenTelemetry community about providing sensible defaults, which is why there's nothing there that looks like where it's going to send. Because what it's going to do is it's going to send all the data to localhost 4317. By default, out of the box, you don't need to do anything. And we'll come on to why that's important when we talk about the collector. So, once we've set this up, that previous one isn't going to do anything. Nothing is happening. It's not going to send any telemetry anywhere because no telemetry is being generated that it's listening to. Now what we've got to do is do some more setup to tell it a few more things. The first one is tell it who it is. Tell OpenTelemetry what this particular application is called. And that's so your backends, where you visualize this data, know all of the different systems. So in this particular one, we're calling it Practical Hotel. In OpenTelemetry terms, it's called a service. The thing that you are running in right now is called a service. It might be a microservice, macro service, gigantic service. I don't know if there's a bigger one than that, but I've seen them. And we can then do the same with logging. There are two separate setups between logging, and this one is for tracing and metrics. So slightly different. All of this is in the documentation for OpenTelemetry. You don't really need to do any pictures for this. The presentation you'll be able to see anyway. And this is the getting started docs that we're talking about here. I built them, so I know what they contain. So once we've told it who we are, we can then give it some static attributes that every single span and metric should have. And these are really useful for things like, which data center am I deploying this service in? If you've got two data centers, one in Denmark, one somewhere else, well, it's important that you know that this particular span was generated from this data center, because it might just be one data center that's slow when you're looking at these spans. And if you're in that container thing, kube or something, pod names, deployment names, service names, these are all individual context that doesn't change throughout the life cycle of that application. Once that application has started, the pod name is not going to change. The data center is not going to change. The region's not going to change. So you can set them once. It's the most efficient way to set properties, and it also uses less data when it's transferring over the wire because it sends them through once and says all of these spans have these attributes. Okay, let's talk a little bit about metrics. Now, I do tend to have a little bit of shade on metrics because metrics are not as useful as traces. They have the opportunity to have less storage because they're time-based aggregates, so we aggregate everything up to 5 seconds and then say this amount of things happened in 5 seconds. And that is a bit of a problem when it comes to looking at granularity, because a lot can happen in 5 seconds. You know, an average system that I've seen, even the low end, is about 1,000 requests a second. 5 seconds, that's 5,000 requests. That's a lot of things that could go wrong in that amount of time. But we can use them, and .NET has had something called meter since .NET 7. It was in 6-ish, but 7 is really when it started, because then they brought in the up-down counter. And what we do with this, and I'll talk about the different ways that we can do configuration of this, but what we do is we create a meter, and we give it a name. Doesn't matter what the name is. And then we create these different metrics off the back of it. And we create them using this meter and say create histogram and give it a name. Create a counter, give it a name. Create an up-down counter, give it a name. These things are then static so that we can then reuse them. But then what we've got to do is we've got to tell, and this should look familiar from the previous slides, we've got to tell OpenTelemetry, can you listen to this meter, please? And when we do that, it's now going to export any of those metrics from that meter into the OTLP exporter. Now it will start shipping data. And when we want to use those, it's pretty simple. We reference our static sales value and record with the markup, and then we add labels. Labels are referred to as dimensions, and they're how you might want to slice and dice this information in the back end. Now, I wouldn't recommend these 3 things here. I use them in the slides because they are what people understand. Data like sales, sale counts, velocity of sales should be coming from a data warehouse that has raw data. Metrics are an approximation. They can lose data, they can duplicate data, so they're going to give you something that's statistically accurate. It is not going to give you 100% accuracy. So if these are things that you're willing to take some statistical accuracy on, absolutely. But ultimately, don't use them for stuff like this. Where metrics are really useful is where there is no context. CPU, memory, network bytes in and out. That's where metrics really come into their own because there's no context and go down to some granularity like 1 or 5 seconds. OpenTelemetry can pull these out using the collector, which we'll come to at the end. So, instrumentation libraries are what we use to get some automatic metrics or automatic traces. They're language and SDK specific, which means that .NET has the ones for .NET. There are ones for the 11 different languages that OpenTelemetry supports. So C#, PHP, Ruby, Go, all of the 11 languages. I think there might actually be 12 since I started doing this presentation. But it's also within those languages. We've also got lots of different types of things we do. We call databases. We call third-party services over HTTP. We call messaging systems. And each of those, if it's popular enough, likely has an instrumentation library that will provide you with some opinionated metrics, logs, and spans for those things. It's up to you to choose which ones are important, which ones you bring in, and whether you might want to create your own span in replace of those with some different data. So in .NET world, which is where I come from, SQL client for MS SQL Server, HTTP client, gRPC, HTTP inbound for ASP.NET Core, you've got MPG SQL, you've got GraphQL, you've got the GraphQL hot chocolate stuff. All of them have their own instrumentation libraries. And it's really complicated to get them in, but it's getting started.
Excuse me, could you define opinionated in this context?
So they will decide that you need to know the SQL statement, that you need to know the values of that SQL statement, that you need to know the connection string for that particular thing, that you need to know the password. For quite a while, the MPG SQL one was outputting the password as an attribute. Don't do that. Yeah, it was an interesting GitHub issue, shall we say. But yeah, the reality is these things are just the getting started. Like the automatic instrumentation that we talked about, this is to get you on that journey. Start with these. Add all the ones in you're using. Then look at what your telemetry looks like and go, nope, we want to remove that one. That's not useful to us. We're using up data, we're using up bandwidth, we're using up processing power to generate that data, and we're not using it. The first one people rip out is Entity Framework, just as a general rule, because SQL Client will give you what you generally got from Entity Framework. But yeah, it's really hard to do. It's really, really hard. You've got to put these 3 lines of code in and put these 3 libraries in. Now you notice that these ones are pre-release as well. The reason why these ones are pre-release is something called the semantic conventions. So OpenTelemetry don't just provide the protocol and the SDKs. What they also provide is a common language, which says if you're generating inbound spans for a HTTP endpoint, then you should, after the host name, is called the target, but without the query string. And that should go in an attribute called http.target. Your host name should go in net.host.name. Very opinionated. They're called the semantic conventions. For quite a while, they have not been ratified. They should be ratified in the next 2 months. We're going to throw a massive pie all over the world because it's been a long time coming, but we've eventually got there. So they're in pre-release at the moment, but only because the names may change in the next months. Now, if we talk about what observability is, and we talk about what OpenTelemetry provides us with observability, it's about debugging your production system. Now, in November, when these things are ratified, if you're debugging an issue that happened in June, I need to talk about your processes because I think you're doing it wrong. You should have probably looked at it in June. So the fact that those names change shouldn't really affect you too much. They are pretty stable. The last release, the 1.5 release of .NET and OpenTelemetry kind of moved towards what we think is going to be there anyway, so I wouldn't worry too much about them. You've also got Entity Framework and MPG SQL. Again, really, really hard. You should start to notice a bit of a pattern here. Instrumentation library, add instrumentation library. Pull in the NuGet, add the instrumentation library. That's how you bring in these opinionated ones. Redis is slightly different. And the reason it's slightly different is because in order to instrument it, we need access to something called the iConnection multiplexer. The reason I include this one is because it's the only one that's a little bit different. And it's different because it uses this particular method here, which is resolved at runtime. So when it builds your dependency injection container, it will resolve this thing here, service provider.getRequiredService, which means at runtime it's going to get the things it needs in order to be able to build it. It runs just after we build the tracer provider. Just look at the documentation for them. They're all pretty easy to do. They shouldn't really be that complicated. Okay, manual instrumentation is really where you should be focusing. This is where we get to be opinionated ourselves and not opinionated from other people. So this is generally where all the bike shedding arguments happen. And people go, no, we should have a span for this. And we should call it this. No, I want to call it this. And yeah, those are the fun times. So I need to take a little quick diversion because I'm going to use terms here that might not make sense to the terms I mentioned before. In .NET 2.0, Microsoft created something called system.diagnostics.activity as a class. .NET has had tracing for the last 15 or so years. So when OpenTelemetry was created, Microsoft went in and stamped its feet, like Microsoft does, and said, well, we're not changing. You should just use our stuff. And I don't know who gave up, but somebody did. And we just went, all right. So what we ended up doing was creating a shim on top of activity. So there is a way for you to use the word span and tracer and attribute by using a shim. Small performance hit by doing it. I only recommend that you use that if you're a polyglot programmer switching between multiple languages constantly every day. If you're not, just use activity because it means you don't have to bring in OpenTelemetry concepts into things where it doesn't need to be. So I'm going to use those two things interchangeably as we talk because I've tried to keep with one terminology and it never works. So if I say span, I mean activity. If I say activity, I mean activity. So what is it? An activity is a time-bound analysis. We talked about what a span consists of. It consists of a duration and a timestamp, which means inherently a span is a time-bound thing. We'll come on to ones that aren't time-bound, which are called span events in a minute, but a span itself is a time-bound activity, which means we talked about a trace being a piece of work, a thing that's being done. Well, a span is within that piece of work a single scope of action that's happening. It might be, I've called a database. I've called a third party. But most importantly, they have causality. That causality idea I talked about. That's what they have. Correlation is something you've always had before. It's not new. We've had correlation IDs in .NET for a long time. But the reason I like spans and activities is they're useful for understanding complex code interactions. You can work out whether something was running in parallel, whether it was running in series. So a fun little story, a friend of mine was working for a bank. They had a particular desktop application that was taking 30 seconds to start up. And he was brought in, he was there anyway, and they said, can you help improve the performance of it? And he went in and said, it's because you're not pooling the connections, you're recreating the connections. They went, no, we do pool them, we don't create new connections. We do them all in a we do them all in an await. It's fine. said, yeah, but that means they're running series. Like, no, it doesn't. No, it doesn't. So he put tracing in. And he showed them it. It's like, no, look. It goes like that. Because when that one finishes, this one starts. And that one finishes, this one starts. And like, no, that's wrong. They swore blind for 2 days that was not the case. And then 2 days later, they went, oh, we fixed it. So how do you do it? So we made them run them in parallel. Computers don't lie when it comes to this sort of stuff. And that's why using that causality stuff to understand that complex code is really important. But most importantly, understanding it when it's in production and when you've got multiple different customers using it at the same time. But basically, it just has everything that a log has and a few bits more that make it more interesting. Now, I said I'd talk a bit about how we set things up. So we create our activity source, which is what our activities hang off. It gives us a context. It gives us a thing that it's called. We do these in one of two different ways. Now, you can use statics. So you can create a static class and create a static activity source. You do not need to instance this. You don't need to. You can use the static and then just use the static to create your activities. That's the simplest way to do it. If you really hate yourself, you can use DI. So you can create a class with an activity source, add it as a singleton to your DI container, inject it in. Now, the question I get asked most often is, well, I'll use it this way, and then I can put an interface around this. And if I do an interface around this, now I can do testing. The problem is that activity source is not an interface. So that activity source is not something that you're going to be able to listen to. You're not going to be able to mock it out. And when I say mock, I mean M-O-C-K, not M-O-Q, because nobody should use that. This is where we work out who's been following the news in the .NET community. So I recommend using a static. It's nice and clean. It's in one place in your application. We use this source name in the same way as we used the meter before, where we add it and say add source. We used add meter before. We use add source with that source name. Now, there's lots of complications around this because activity source is just a name, really. It's not a thing that anything actually uses. It's a shell. It just creates activities with that name as its source, which means if you create 5 of them with the same name, they all go to the same place. So that's why I say just do it as a static. It's not special. You can do it via DI. My overriding principle when writing code is local consistency over global consistency. If everything in your platform is using dependency injection, it might make more sense to use dependency injection because the cognitive load of somebody coming into your platform and finding some things are using statics and some things are using dependency injection is far worse than just using dependency injection. So local consistency over global consistency. So once we've got that activity source set up, now we can create our manual spans. So this is a little bit of code. I firmly believe this is how retailers work out how to charge people. Just add a random number to the price each time. The key part of this, don't ever use this code, by the way. The key part to this is this element of code here, this for loop, can change its performance based on inputs. The higher this category ID gets, the more iterations of this loop we're going to do. You've probably got things that you're thinking of now in your platform that have those same characteristics. The inputs will change the performance of a particular element of that application. I said this is about time-bound analysis. That's the thing that's important to us. So we can instrument that by adding our own span. And we do that, and I'm going to use my static example. Diagnostic config.source, start activity, give it a name, and then set some context in different values. This thing here should be what we call low cardinality. It shouldn't have variables in it. It shouldn't change its name dependent, so we don't add the category ID on the end of this name. It should be low cardinality. These things are where your cardinality goes. Add them as separate properties. And we're wrapping this bit. And then we're adding some output, which means we've now got an object here that's going to be output into our tracing system, a span that's been created. And it's going to have all these 3 bits of context on it, and it's going to have this name. It's also going to be part of a wider trace, which means we can see how this particular thing has affected the overall performance of that request. Best practice. This is where the bike shedding comes in. Because everybody should use consistent language. I talked about the semantic conventions that OpenTelemetry give us. Well, that's about providing a shared language for the backends to understand. Because if everybody uses http.target or http.useragent or http.isbot or all of these different things that come in, the backends can do something interesting. Inside of your environment, if you've got an application where you've got some common concepts like account or user or product, when somebody adds the ID of the product that was coming in to the telemetry, they should all use the same name. You don't want one team calling it product_ID, another one calling it product.id, another one calling it product.product_ID, another one saying, well, no, this is products, so we need plurals. We've all had the plural database names debate, yeah? Yeah. But this is where you need to get it right. You don't need to get it right all the time, but if everybody uses the same name, it means the telemetry that you're looking for in the back end is going to be more useful to you. Because when you see product.product_ID, you know what it is immediately. So that would change this code to look, in my opinion, a little bit nicer. When I'm looking at code and I see magic strings everywhere, it scares me. Because anybody can change them at any time, accidentally, a bit of refactoring, a find and replace. There's a problem. But the other thing is, if you're using a modern IDE, you can go to this class and say, find usages of this particular thing. And you can find all the places in the code where that particular value is used. What you're essentially doing here is designing that debug experience, because it might be one of your colleagues. It might be you at 2 a.m. Because at 2 a.m., I have the intelligence of a 3-year-old. I did put that on, did you notice there? That's my home doorbell. Now that's true observability. So adding a class like this with constants in is really useful. The next level of this is adding these into a shared NuGet library so that all of the different services can bring them in. But only do this for shared concepts. If the concept that you're working on is not shared and only exists in the service that you're working in, don't try and apply rules that mean that people have to put it in a centralized location. Because they won't, they'll just use strings. Provide them with a class like this inside of their assembly, so they put them all here. You don't have to always do it. Magic strings sometimes work, but they should be constants. All these tag names, low cardinality. Yeah? It's not product.categoryID. The actual ID. Yeah? So, slightly better code now because we haven't got any magic strings everywhere. We've got actual context. So it's the new product price ID. We've actually got some actual text that makes sense to me. But under the hood, it's applying a constant string. Now, the other thing I see quite a lot is people wrapping concepts. So people creating the Adora activity, because our activity is special and we want things to be created in a very particular way. So we're going to create our own special version of an activity, and it's going to have our own methods on it. Now what we're doing there is we're taking away people's agency to use other tools. Tools like the actual methods on activity that might be important. So what we do instead is we write extension methods. So we write an extension method on activity source that says start an activity source with some tags. You could provide some typed data in here. Say start an activity for a product and pass in a product object, which then starts an activity and passes in some product tags. Extension methods are way better than providing a wrapper. Because now, yes, start with tags. You've still got that thing that you wanted, that actual words that say, activity source dot started or activity. But under the hood, everybody's got access to all of the things that come with activity. Roslyn analyzers are becoming so prevalent in the industry right now. And if you write your own stuff, you miss out on all of the analysis that you get from using the tools that the industry has created, because they don't know that your activity is actually an activity. I want to talk a little bit about activity.current. Now, when we create spans, we create a span or we start a span. 99.99999% of the time, you will do start activity. Now, what start activity does is it creates a new activity object and it marks it as the current activity. When we then create another activity, it creates another activity and puts this one as the current activity. Now, these two may look the same, but this activity tag that we've done here is not always going to be added to this index activity. Because if I've got another activity running in the middle, it's going to use that one. The way you combat that is instead of activity.current, use the index activity directly, if that's what you want to do. Be aware that activity.current is great and gives you access to the currently running activity wherever you are in the code. It uses something called async local, which means it works in any context, and it will get the currently running activity and allows you to add tags to it. And a lot of the time, that is where you want to be doing. You want to be not creating activities, you want to be adding context with tags. As an example, if you've got, say, a search controller action, instead of creating a new activity inside there, if you've added the ASP.NET Core the instrumentation library for ASP.NET Core, this is always going to have a currently running activity. You don't need to create a new one. You can quite easily just add a tag to the current activity. Because observability is really about wide data, not deep data. The wider the data, the more context you have in order to be able to query that data more effectively. If you have deep data, then you can see the interactions clearer, but that doesn't mean that you can find problems faster. So I said we'd talk about the non-time-bound analysis, and that's something called span event. Basically, a span event is a log, but a span event is attached to a span. In .NET, we call them activity events, but they're the same thing. And it means a point-in-time action. Something that happened at this time. It doesn't have a duration. All it has is a timestamp. But it does provide us with some extra context. So it can provide us with things like some extra tags, and it's attached to our span. So we know that this span was executing and this happened at this time during this span. Really useful for things like exceptions or validation things that happen. But because it's attached to a span, it means that when we try and sample data out, which is what we should be doing to try and reduce data volumes, these are sampled out at the same time because they're intrinsically linked to the span that was being created. like I say, it's basically just a structured log, really. Because if you think about what we were talking about before, if it doesn't have a parent ID and it doesn't have a duration, it's basically just a log. But the object is attached to your span object. So if you drop your span object, you drop the span events as well. So we'd use this, there's the list of attributes that you get. Like I say, that's pretty much what you'd have on a structured log. So here's an example of using it with a validation event. So you're going to do some validation. You might want to have some extra properties. What I will say, 99% of the time, you're probably going to put those attributes on the current span as attributes on the span rather than create an event. When it's something like validation, you don't really need to know that in the 4 milliseconds it took to run that request, at millisecond 2 was when the validation happened. It's not really going to be useful to you, which means you've now got more depth than you've got width. So go wide, don't go deep. But you can do that like this. You create an activity event and you add that activity event to an activity, whether that's the current one or an activity that you know about. It's entirely up to you. The key here is what I'm doing is I'm giving you different tools so you can choose the right one when you're writing your application. I don't know the applications that you write. I cannot know every person's application. I'm happy to answer questions about them, but I don't know, so I can't advise you on one size fits all for all of this. This little method here is something that OpenTelemetry provide as a nice little extension method. So this record exception does add an activity event. Under the hood, it adds an activity event, and it will add this tag list of different things to it. It adds an exception.message, exception.stacktrace. Again, something that's very opinionated. And the reason why that's opinionated is because exception.message is in the semantic conventions. Because if you use an exception.message, the backend knows if it sees exception.message, it knows that an exception's happened. If it sees exception.stacktrace, it can render a stack trace like a stack trace, not just as a field.
I think we soon should take maybe a 5-minute break or something.
Yep, we were scheduled to go for another 5. I've got a nice little convenient point, so we'll do that. Okay, span links. Span links are incredibly interesting and vastly underused in my opinion. A span link is how we link two different spans together without saying they're part of the same trace. Now, trace is one big, deep thing. Now, it might be that what you want to say is this other span in this other trace is related to this span in this trace. And you use span links to do that. Why might you do that? Various reasons. We'll show you an example using service bus in a minute. Now, this is what we call a causal link versus a causal link. A causal link is parentage. So I ran this thing caused this thing to happen. So we see them in this nice little trace waterfall. But we're trying to say they're not dependencies. And that is interesting when we get into messaging structures, because messaging can happen async. So yeah, the one happens on the other. They're not the same trace, so it transitions two different trace contexts. I'm thinking ahead to what the next slide is at the moment because I'm trying to get to that point where we can take a little break. So yeah, we talk about traces as parent and child. We have a root span, which is the one that doesn't have a parent, and then all the children. So this is an alternative to that. It's just a different way of modeling data. So when we create span links, we can only create them when we create the activity. You can't posthumously add them. So you can't go back and say, oh, but now add this link to that trace. Don't ask me why, because nobody I've spoken to on the OTEL committees can actually tell me where this thing came from, but it's what they've done. But we add them and say, we pass in a context, which is the activity context or the span context. We can create those up. And then we add those when we start the activity. Now, in this particular example here, what we're doing is we're sending stuff into the background. When we send stuff into the background, it might not happen at the same time. In this particular example, it will. But let's say we add this to something like a background service, maybe we add it as a background job in Quartz or something like that, and it picks it up in an hour, in 2 hours. Traces of a time-bound analysis. If we've got a span that lasts 10 milliseconds, and then 2 hours later we've got another span that lasts 2 milliseconds, how do we model that? We've got 2 dots on a screen. Is that useful to our analysis? Probably not. What was probably useful, though, is to be able to say that this email activity, when we sent it 2 hours later, is related to this particular trigger that happened. That might be useful for us to see. But your context, not mine. No, just another tool. So we want to take a little break now, and we'll talk just after this about processors, which is kind of like pipelines for creating and manipulating telemetry data. Yeah?
So 5 minutes.
Cool. ASP.NET Core, you'll be very familiar with them. The idea is that you can run something on the start or finish of a request. So whenever we create an activity, we can tell it to add some extra data to that activity. Whenever we finish or dispose of an activity, we can do the same thing. Which means that we can do some interesting things with adding additional context to that stuff. The problem that we've got, though, is there is a performance impact in doing this because they run synchronously. So when you say create activity, before that activity is returned to you in your code, all of the processes are run. So in this particular example here, we're going to create a tenant ID processor. Now, if I had a thread.sleep in there, that's going to impact everybody else's code. Now, no self-respecting developer is going to put thread.sleep in there. But you would put a database call. You would put a third-party call in there. Don't. Because if you put it in there, every single time an activity is created, whether it's yours or one of the instrumentation libraries, it's going to run that code. That is not the right place to put it. So, basic example here is grabbing out of the headers of every HTTP request the tenant ID, so you can augment every span with a tenant ID. Pretty simple. You can inject stuff into these things using that configure provider like that, because you can access the service provider. They're not complicated, pretty simple, just dangerous. So be careful. Speaking of being careful, we're going to talk about baggage. We're talking about open telemetry baggage. Therapists can deal with emotional baggage. So open telemetry baggage is this idea of how do we transmit extra context about our traces between services when we're doing a microservice architecture. But it isn't to do with putting an attribute on every single span. We don't add baggage and then expect the baggage attributes to be on every single span that then gets created afterwards. That's not what baggage was meant to do. You can make it do that. You can write a processor that on the end of every request goes to baggage, iterates through it, and adds them all as attributes. You can absolutely build that. But ultimately, that's not what they're there for. They're there to influence the telemetry that happens on those descendant services. But it doesn't come from open telemetry. It comes from something called the W3C trace spec, which is part of W3C, not part of OpenTelemetry. Transcends OpenTelemetry. It's really dangerous. And the reason it's really dangerous is because it's prolific. It doesn't care what service you are calling. It will add baggage data. So in this particular example, I'm adding baggage for account.name. The name of the person that is currently executing the request is now on baggage. And then I'm going to call out to my inventory service, which means that the baggage is going to be passed over to that inventory service so that I can use it. And I can, by the way, everybody should have this code in their platform, just to be clear. So if the account name is martin.net, set a tag saying is VIP. I'm trying to make it a thing so that it's in everybody's platform. I'm not sure it's working. Now that's cool when you're inside of your own service, your own system. It's not so cool if that wasn't a call to inventory service. What if the domain on that was evilcorp.com? Now all of a sudden you've transmitted that context out to a third party. And it seems innocent. This really does seem really innocent. I'll just add that. I'll pass it over here. And I'll use it. It's great. The other bad thing is this is a string. And because it's now available in my backend service, I've now got a really cool way to be able to take some context from one service and pass it over to another service to use it. So what if I needed the person object in the other service? Oh, great. JSON.serialize person. Why has our bandwidth gone 3 times what it normally is? And that's a big problem. Anybody remember view state in web forms? Because nobody ever persisted a data set to their view state. No, nobody would ever do that, would they? Nobody ever got a 7 meg page load because they put in the entire data set on every request back and forward. No, nobody would do that because that's stupid. But that's what can happen here. It can happen because I've seen it. So that's why I say it's dangerous. It's prolific, it can go anywhere, but it can also be really misused because in this code here, I could quite easily do get baggage, deserialize the person, and then use the person for some other code that I've got. That isn't what baggage is for, so just really think about what you're using it for. And that brings me on to propagation, because propagation is how we take a trace context from one service so that the next service that we've just called uses the same trace ID and uses the same baggage. And that's called propagation. Now, if you're using ASP.NET, if you're using HTTP client, you need to do nothing. It will do it all for you. However, if you're using messaging systems, there's a lot of things it just can't do. So propagation is about trace context, it's about trace ID, it's about the current span ID, so that the new system can get that. With HTTP, it's automatic in all languages. But it isn't just for HTTP, and we can use some custom stuff. So if we were doing Service Bus, or RabbitMQ, or, God forbid, ActiveMQ, or MSMQ, it works in all of them. Ask me why I know. I'm only 18. So what we can do is we can inject that context manually ourselves. So we've got our Service Bus message. We can say inject the current context into message, and this is how you do it. So we tell it how to access the application properties object, which is basically headers for messaging. We can tell it how to access it, and we give it the object we want to add it to. And then on the other side, we do the opposite, which is extract. We can extract it into a new activity context, and we give it the application properties and tell it how to access those properties. Fun little bit there. You can see that it's returning an array of string, not an individual string value. That's because headers are multiple values. And most people miss that because you can provide the same header twice in HTTP and you get an array. Same with doing it with query string parameters, which is why that comes back as an array everywhere, because core to HTTP is that it can be an array. And then when we get that new activity, this context, we can then start our new activity the same way as we did before, but we're passing in the parent that it needs to be parented for. But you can also do that with links as well. So you can use that same activity context as a link instead. Okay, sampling. We'll go through this really quickly because it's a really complicated subject. So we'll go through it quickly. Doesn't make sense, does it? The reason we're going to go through it quickly is because there is practically an entire 4-month course that you can do on this. It's really heavy maths. There's a couple of different ways that you can do it. The main thing that you need to be aware of is why you would do each one. The rest of it is go away and research and have a look because it's really complicated. Morten can tell you that. He did some stuff in the workshop with us. It's not easy. So there's 2 types, head sampling, tail sampling. What that allows us to do is retain the context of a full trace, but it allows us to say that I've got this trace, there were 1,000 like it that I didn't send you. But I get all of that deep trace that you've created. And I can say there were 1,000 of them. Which means your backend systems can extrapolate when it's drawing graphs and say, yeah, we got 10,000 requests because I can see 10 of them. So we sample by taking 1 or 2 of these and then providing a number that says this is how many they represent, which allows us to retain the context. It allows our querying to know what the relative values of each of these things are. It is incredibly hard to do well. It is really easy to do badly. Because if you randomly take every 1,000th request and go, yep, that one, and then ignore the other 999, you don't know whether you've hit all of the routes. You know, that 1,000th request every time could be a health check. It's really easy to do badly. It's really hard to do well. But we do it so that we reduce our storage. We don't have to store as much data. It means we don't have to transmit as much data onto the back end that's going to analyze it. And because of those 2 things, our querying ends up being faster. And that's the key to observability, is how quickly can I get the answers to the questions I want to know. So head sampling happens before we create the activity. It happens inside of your application. But there's a lot of problems with that. A lot of advantages, because if I know I'm not going to create any activities, I know I don't need to do any of the object creation. I can forget about all the unboxing. I can forget about all of the stuff that comes with building out that trace as I go. Because I know I'm going to have it or I'm going to not. But the big problem is it has access to very little information. I don't know whether this is going to be a 500 error. I don't know whether it's going to be a 200 OK. I don't know whether it's going to be slow. I don't know whether it's going to be fast. I don't know any of that stuff. Because all I've got is things like the URL, the user agent. That's what I've got right at the start. By contrast, tail sampling happens after a span has finished, after a trace has finished. And by trace, what we're meaning is whenever the root span has returned, we're going to assume that the context has finished. We're going to wait a little bit of time to get all these other services to all get their data into one system that exists really close to your network. We're going to buffer all that up, and now we can make a decision based on any of those attributes. It's generally run as something called the collector, which is a service that OpenTelemetry provide. But it has access to all the data. It has access to every attribute on every span that's part of this trace. It has access to all of the traces all the spans in the trace. Now, I said that how quickly we get the answers to our questions is really important. But if I've got to wait for a delay after this, that's going to delay me getting the questions from my backend system. Might not have an impact on you, because it depends on what the SLA of your background system is anyway. There are observability platforms that have a 5-minute SLA from when you send the data to when you can view it. Delaying 20 seconds, you're not really going to see it. So Morton's asked me to do a demo of Honeycomb. Our ingest time is a second. Guaranteed less than 3. The 99th percentile is actually about 200 milliseconds from when you send the data to when you can query it. This really has an impact when you do tail sampling, when you're used to being able to see it. That delay, when you're in a outage, any delay you get in telemetry feels like an eternity. And that's why people actually end up going into the site themselves to work out whether it's working, instead of relying on telemetry. If you can get the telemetry faster, you can rely on the telemetry. Now, you can write your own samplers. Don't write your own samplers, but you can, because as you can see from this one, it's just going to do a random percentage of everything that comes through. This is doing it badly. Don't do this. But you can write your own samplers. And you write them by using these sampling parameters, so you've got access to the data that was available at the time when the span was created. Okay, so we do the tail sampling in the collector. The collector is an amazing piece of kit. It's an amazing piece of kit for a few reasons. One of the reasons is it centralizes config. So when you're sending your data to a backend, generally there'll be some kind of authentication, maybe some API keys to make sure that things don't get sent from the wrong things. If you've got, let's say you're Monzo and you've got 1,500 microservices and all of them are sending directly to your backend, and then the security team turn around and say, the API key's been compromised, I need you to redeploy all of your services with the new API key in the next 5 minutes. At which point we all cry and then ring our significant others and say, I'm not coming home tonight. If you're using the collector, what's happening is all of those systems are sending to a local collector that's close to their services. And that thing is the thing that's sending onto the back end, which means you're going from changing 1,500 things to maybe 10. And you can chain these together. If you're working in a hyper-secure environment, your edge nodes, your services, probably won't have access to the internet. They won't have access to egress the data, even inside of your network, to go out through your proxies. What this does is allow you to say, well, I'm going to send to the collector. And the collector is what's going to forward on to the other provider over the VPN connection that we've got with the other data center, where all of the observability stack lives. So your services don't need access to the internet, which means the security teams love you. Like, if you really want to get on the security team's good side, learn the collector, because there's so much stuff. It can do filtering and redaction. So it can say, well, if I see a number that's 16 digits long and starts with a 4, I'm going to mask that because that's a card number and we shouldn't be sending that. You've probably got a regex that will tell you maybe the account number or some specific identity service number. Like in the UK, it'd be our driving license. There's a regex that can identify driving licenses. You don't want to be sending those. Talk to your security team and say, you know all those things you don't want us to send? I can give you a regex. And it will blank them all out. They will love you. But it also does things like enrichment. So it can also say, you don't need to know your service was running in data center A versus data center B. You can have the collector in data center A automatically add that to the spans as they get forwarded on. It's broke up into 3. We have receivers, we have processors, and then we have exporters. The receivers can be anything. OTLP is the main one, which is our Open Telemetry Line Protocol, but there are Jaeger receivers, Zipkin receivers. You can send stuff through messaging systems and have the collector pick them up. All of that stuff is available. It picks them all up, runs a consistent processing pipeline from things like enrichment, redaction, all of that kind of stuff, and then we'll export it wherever you want to go. So if you've already got a Jaeger instance, Jaeger's a really bad one to put on this. It's an old diagram. Jaeger now accepts OpenTelemetry relying protocol out of the box, and the majority of tools that you use will accept OTLP out of the box. If you're using, say, Signos or Grafana Tempo, any of those tools that you can host yourself generally accept OTLP. It's really useful if you've got a legacy Jaeger cluster, because you can put this in the middle. You can accept Jaeger and push Jaeger out the other end, and then you can also push out OTLP as well, and you can do partial migrations. It's really, really cool. Again, a topic in its own right. So that is the main part of the demo of the talk. Do you want to do questions before or after Honeycomb?
I think you should show what you can use all this data with using your Honeycomb as an example first.
Cool. Okay. So I'll just have to fill while ClickShare decides to do its thing. I apologise for the people who are remote. You just have to view the screen, unfortunately, because it's on a Teams call. So Honeycomb is a tracing-first provider. We accept raw tracing data, we accept metrics, and we accept logs. But we can build graphs based on raw data. We don't need metrics. You don't have to pre-aggregate data. That quickly becomes a superpower when you are trying to debug systems. Because being able to ask a question at a very, very granular level to say, how many users was this thing that we're trying to look at the moment? How many were affected? Take, for example, we call it intersectional analysis. Take, for example, you've got an error that's happening on only iOS 14.1 for people in Norway that are currently located in Norway, but have the French language pack enabled. Now, if you've built a dashboard that will tell you exactly that correlation, I'm afraid you're doing it wrong, but go you for thinking about it. That might be the only time this error occurs. The rest of the time, it's fine. Being able to ask that question and say, these errors that are happening, what are the most common properties for all of the things where it occurred? Well, that is the superpower. There we go, connecting. And that is where we've kind of excelled. We wrote our own back-end database engine specifically for this. Charity Majors, who's our co-founder, wrote the book Database Reliability Engineering. She used to run the infrastructure engineering teams at Facebook. And Linden Labs, if you remember Second Life from way, way back, that was her doing all of the infrastructure for that. But she wrote the idea of database reliability engineering, in which the first paragraph is, never ever write a database. And guess what she did when she left Facebook? She went and wrote a database. But she wrote a database that was very specific to telemetry data. It's not some relational database. It's a variant on something called a column AR store, which is a different way of representing data in a database format. And what that's telling me we're just coming up to time. And that doesn't want to load in.
Maybe I can add while you fix that. When all this data is getting sort of, for analyzing all this data, you're using a provider. And a provider can be, that's basically a GUI application tool where you can look at your data. And there are open source providers, Jaeger is one of them. But there's also commercial providers, and this is what
But you can also do both.
Or you can do both.
You can also do both. So we talked about the collector. And one of the cool things about the collector is you can do something called dual send. Because we can accept open telemetry line protocol data. On that left-hand side, we had all the receivers. On the right-hand side, we had exporters. We can add as many exporters for the same receiver as we want. So you can choose to use, and we do get a lot of customers who do this, where they will write all of their telemetry data to long-term storage. Whether that's cold storage hard disks in their data center, or it's a cloud backup platform like Glacier or something like that that they can push it to, because they want to keep it for compliance reasons or because security say so. They want to keep all that data. When we do production debugging, we don't need the length of time. It's still not connecting.
But do you have HDMI?
I do have HDMI. Okay.
That's the benefit of having a technical CEO.
Oh, look at that. That just works. Oh, that was so complicated. Okay. So what they do is they will use different systems for different reasons. I did too. I mean, this is where we gaslight everybody in the room, so you can see it, can't you? Yeah? So this thing here. Now we're back. Nope. Right. There we go. Yeah, there we go. Nobody breathe. So what they'll do is they'll use the same telemetry data for different things. If you're doing production debugging, what you want is fast answers to questions for a short-term amount of data. 2 weeks, 4 weeks, 6 weeks. Yep. This is because I have to connect to the internet and I try not to connect to the internet. So they'll use that. They'll send some for long-term storage, some for short-term storage, and they'll use it for different things. And they use different tools, like heuristic analysis of errors might be one system, production debugging might be another. This is Honeycomb's main dashboard for a particular microservice platform that we've built. So it's about 11 different services. It's based on the old, if you remember Mesosphere from way back in the day, which was a Google platform, the precursor to Kubernetes. They built this hipster store, which was like 11 different services in different languages saying, great, you can deploy all these things, and they'll all work together. What we've done is we took that and we instrumented it with open telemetry. So we don't have an SDK, we don't have an agent. Kubernetes, the Kubernetes platform is what we're using, and then we're using a collector in there. All of the services are providing their data to the collector. The collector is the only thing that has the 3 lines of config in it that says, here's Honeycomb, and here's the header that you need to pass with the API key. That's the only thing that we've done. The thing that we have done 2 other things. We also added in things like user ID, because that's really useful data. And we made it fail every 4 hours, because otherwise the demo's a bit flat. So what we've got is if I run that for last 2 hours, let's run into here, and then I'll analyze it. None of this is using metrics. This is all raw tracing data. It's querying about 24 million rows. It's about 4 million rows per hour that we get. And it's querying all of those in real time. So what I'm going to do here, I'm looking at the front end, which isn't the front end. It's the back end for the front end. So it's the front end of the back end, but it's not the front end. It's a BFF or an API gateway, whatever you want to call it. They called it the front end at the time. BFFs weren't a thing back then. Now, if I change this and I look at this and say, I want you to generate a percentile graph for duration. So what I'm looking at here is the last 8 hours on a P90. P90 means the fastest 90%, or the other way of putting it, exclude the slowest 10% and show me what the maximum is. That's what a percentile gives us. Now you can see there's no problem, everything's fine, everything's responding in about 800 milliseconds, everything's great. Now when we get to a point where we're using raw data, we can actually do something called a heat map. Now a heat map is a 3-dimensional graph. And a 3-dimensional graph, because we've got time across the bottom, we've got duration up the left-hand side, but then we've also got this density. The darker colors are where more of these things have landed, more of these route requests have landed. So if I zoom in over this bit here, we can see that the majority of our requests are landing in 500 milliseconds. Other than that, about less than a second, but we've got a load of outliers. Looks like something's going wrong. But everything's fine, right? Our P90 metric says everything's fine. But 10% of our users are having a problem. Now imagine that as a P99 or a P999. At Honeycomb, we run on a P99999, 5 nines, because the volume of your data is important. Because of this, we can actually do some really interesting analysis because we don't just have pre-aggregated metrics at this stage. We've got the raw data. So what I can do is I switch into something called Bubble Up. What we established was humans are really good at pattern matching. I didn't need to tell you that that was a problem. Your eyes immediately went there, and that's because we're really good at pattern matching as humans. Computers aren't that good at pattern matching. Apparently, they're really, really good at crunching numbers, like adding things up. It's almost like they were built for it. So what we're going to do is we, as humans, are going to tell the computer that there's something interesting to look at, and the computer's going to do what it's good at and do some number crunching. So I can draw a box around that. And that's going to go through all of those different attributes that we just talked about that we add to our spans, that wide data. It's going to go through all of them, and it's going to tell me what's common about the spans in the yellow box versus the stuff outside the yellow box. Now again, you're good at pattern matching as humans. Your eyes are immediately going to go to the discrepancies in that graph. You're going to look at target, name, route, big yellow bars. So I know that actually 100% of my selection is on the checkout.cart. Every single one of those calls is to do with the cart. That's not really that impressive because everybody's got a metric for the URL, right? But what is impressive is, if you look down the left there, it's actually a single user. It's one single user that's having a problem. At this point, if you're investigating an issue at 3 a.m., you go back to bed. But if that's yours, then nobody's going to go to bed. If that's your user ID, nobody's going to bed, honestly. That's a career advice, not telemetry advice, just to be clear. But we know that that's one user. And we know that because we're querying raw data. But I can then rewrite that graph and say, show me just that one user. So what happened was that user came on, they had some problems and went away. It's a really interesting way to look at this because if that user came online, had a bad experience and went away, you know you've got a user dropped. That's a user you should probably caring about. But the other thing is, we can actually click on any one of these dots because every one of those dots either represents one trace or multiple traces. So I can actually pick any one, whether it's a slow one or a fast one, and then I can go into a trace view. This is the uninteresting bit. Everybody's got one. If you know what trace ID you want to view, Jaeger's actually way better. The problem is knowing that it was that trace ID I want it to view, that's the hard part. So I've now got this trace view. I can now click through. If you look on the top right of the screen, you can see we've re-rendered the heat map, and we can start to see, well, for each one of these spans, we'll re-render the heat map based on that name. Am I in the slow one or not? Well, I can go on to the get discounts and like, oh, this is 5G for you. We're right up at the top. We're in one of the erroneous spans, so it's definitely to do with this particular span. But if you look underneath, there's a SQL query, and you can tell it's a SQL query because it's just got select at the start. If I click on that one and look at the heat map, it's actually about as fast as it normally is. You can see the density's increased. So we know from looking at that there wasn't a problem when we looked at percentiles. We went from percentiles into a heat map. Oh, yes, there is a problem. From that one, we know that it's one individual user that's having a problem on the cart. And now we've gone in and found out the problem is actually in the checkout service for the get discounts call, and for some reason we're calling the database more. Now, I've been in the industry long enough that I used to get tickets saying Dave's having a problem, and that was the extent of the context of the ticket that I got, to which one I respond with, well, I'm not. Not career advice. Don't do that. This is gold for debugging for developers. If you get a bug and you get this level of information, you are fixing that issue in minutes. Now, because we're also using raw data, there's a concept I want to introduce you called service level objectives, SLOs. I don't think there's any kind of coincidence that it sounds like slow, that they do help you monitor slowness. Service level objectives are about the idea of you having contracts between you and your product owner about how broken your system is. So I want to take a minute, and I'm really sorry about this, but I need to tell you that your system is broken. I don't know your system, but I can tell you it's broken. Because every system is just a little bit broken. It's all about the degrees of broken that we accept. Nobody has zero errors. If you do have zero errors, you're probably spending your time in the wrong place. Errors are inevitable. It's all about how broken do we like it. So a product owner can come to you and you go, right, how broken are we allowing the system? And they go, oh yeah, it can't be broken at all. It's like, not having any new features then. No more deployments. That's just what it is. They go, oh, okay, well, maybe we can have like 1,000 errors a month. That sounds about right. It's like, great, okay. So, guys, 20-second response time is cool. He just said he just wants errors. And they went, no, whoa. An error is also less than, more than 2 seconds. It's like, great, okay. So now we've got a contract of what constitutes an error that we need to be able to have as our contract. That's now a functional requirement of our system, that for every month we can only have this amount of things that are either an error or less than this amount of time. It might be two separate ones, but this is all about that negotiation that you have. Now, if you're basing things on P99, you've already excluded 1%. You've already excluded the slowest 1%, so we know that those are already over your limit. So now you've got to be able to say, well, now I need to get it a bit lower. If you base it on raw data, you don't need to do that. Because we can say the number of individual events, individual spans, that have caused a problem, that have caused us to exceed it. And we do that using something called an SLI. And this isn't unique to Honeycomb. SLOs are a widely used concept. They're available in things like Prometheus and Grafana. All these are concepts that are not specific to Honeycomb. We do things a little bit differently because we use raw data. And what that means is we can say, this is what we call a service level indicator. That's the contracts that you've had with your product owner. In this particular one, the only thing that constitutes a user latency SLO being fired is if our root span, the one at the start of the trace, is more than 1700 milliseconds. So a good request, less than 1700 milliseconds. A bad request is more than 1700 milliseconds. Sounds pretty simple. We then have a budget. We can do X amount bin in the month, and we can start to see how we're burning through that. The reason this is important is alert fatigue. If you are woken up by an alarm on PagerDuty or whatever tool you use to get your on-call people out of bed, and they get up and the error has resolved itself, you've wasted that engineer's time. That's how you get burnout in teams. It's also how you get people ignoring alarms. It always goes off on a Tuesday, it's fine. It's the equivalent of the boy who cried wolf. Everybody knows the story. Well, the alarm always goes off on a Tuesday. No, the world has just ended. You really need to do something about it. Yeah, but it always goes off on a Tuesday. It's probably nothing. SLOs provide us with this ability to say, no, I will only get you up if it's going to be burnt in the next 2 hours. Unless it's going to be burnt in the next 2 hours, it's not really a problem that we need to deal with. If it's going to be burnt in the next 2 hours, PagerDuty, send a bailiff round to somebody's house to get them out. That's serious. If it's going to be burnt in the next 24 hours, it's probably not a real big problem. So drop it into Slack, drop it into Teams. Somebody will pick it up when the stand-up happens, when they're nice and fresh, and it's just part of their day. If it's going to be blown out in the next 2 weeks, put a ticket in Jira, it'll go into the backlog of death, and everybody will ignore it, everybody will be happy. But you can set different thresholds that are then, again, your contract with your product owner to say this is how important these things are. The reason Honeycomb does this differently is because we know each event, we can actually do a bubble up and tell you exactly why your SLO is being burned. We can tell you exactly that it's one individual user. And what's really cool is because that's a little query at the top, this SLI, if I get woken up by one user, I'm also going to put in there, and user is not this user, and redo my SLO. But that's the power of using raw data, and this is what you should be getting used to. Using telemetry only at the point when you've gone live and there's a problem means you're not used to looking at production. Production should really be part of your team. Are you able to deliver value to a customer without production? No.
And I think the TV thinks that presentations are always right now.
It's fine. It's fine. I mean, that was the last bit anyway. But the idea is that you should be really thinking about how you use telemetry in your daily work. Be constantly asking questions of production. Are you okay? That thing I've just done, is it doing what I thought it was doing? Don't rely on your metrics and your logs and your traces to only get you out of a jam when things have gone wrong. Use them constantly. Get used to running queries against whatever platform it is that you're using. Make that platform work for you so that production isn't scary. Those big blinky lights in the cupboard in the corner that look evil, they're not. They're just another machine that everybody else is using. That's really what OpenTelemetry is about. It's about bringing production closer to you. Not install an agent and hopefully the platform that you're using will tell you when things have gone wrong and why it went wrong. And you only find that out when an error happens, when everything is on the plate, and when everything is on the line, and you're trying to use that platform. Get used to telemetry. Add some stuff in your code. Go and see what it looks like. Add some stuff in your code. Go and see what it looks like. Do I get the right bits of information out? But that's me. That's Honeycomb. We obviously do loads of other stuff, but those are the key things that transcend what Honeycomb does. Happy to take any questions.
Maybe over pizza?
Over pizza is absolutely perfect. I'm not going to keep anybody from pizza. I don't want anybody to hate me.
Thank you.